Today we're going to look at the third way of writing out an orbital diagram, electron configuration, and a noble gas configuration. There are three different types. If the directions tell you write out an orbital diagram, that means that you're going to draw it with the arrows spinning in two different directions with all the little orbitals all lined out. If the directions say to write out an electron configuration, again, you're going to write out everything, but as you write it out, you're going to write out just 1s2, 2s2, 2p6. So you're just going to use letters and numbers. The final way of writing these is actually the shortest and most compact way of writing out an electron configuration, and this is typically what a chemist is going to do when they're writing them out. It's called a noble gas configuration because it uses the noble gas. A noble gas is the group number 18. We're going to learn this in the periodic table unit. But when we get to the periodic table unit and we look at those noble gases, we're going to find out that they have a full valence shell. So if you go on beyond that noble gas on the periodic table, you're going to find out that you're going to jump up to another energy level. And when you jump up to another energy level, you're going to have some more electrons on the outside. So a noble gas configuration just focuses on the noble gas, which has a full valence shell, and then you're just going to look at where are our valence electrons located. So in order to do these, you're going to have to know what is a noble gas. And on your periodic table, you have your noble gases in group number 18. So when you look at group number 18, we have helium, we have neon, argon, krypton, xenon, radon. And then this one down here does actually have a name. Nope, it's not oganesson because that's going to be 117. 118, it's escaping me right now. It's going to hit me in a minute. But that one is a noble gas as well, but you'll never use that one because nothing goes beyond that on the periodic table itself. So with your elements in group number 18, what we're going to do is we're going to identify the noble gas in the group above it. So when we identify the noble gas in the group above it, whatever element you're dealing with, that says, okay, the reader can figure out everything in that noble gas. We're just going to continue on after that because we want to know just where are our valence electrons located. And as we look at the noble gases, it's the last full period that you're going to look for. So as you know what, that is oganesson. It's OG, oganesson. I knew it was going to hit me. Sorry, side note. So with your noble gas that you have, you're going to find your element that you're dealing with, jump up to the last full period, and you're going to pick that noble gas. That noble gas is going to go into brackets. And then from there, we're going to continue on with the beginning of the period of whatever element it is. So your noble gases are down here. So if we're dealing with aluminum, which lives right here, I'm kind of circling it right now on the periodic table. So with aluminum here, we're going to jump up a row to the very end. And the noble gas that I'm going to choose is right here, which is neon. If you have this element right here, which is calcium, if you're dealing with calcium, again, we want to know the element at the end of the last full row. So you're going to go up, you're going to go to the very end down here, and we go to the very end down here, you're going to pick argon because it's the end of the last full period. So you're going to pick that noble gas. And then once you pick that noble gas, you're going to go to the beginning of that period, and you're just going to continue on like you had written everything else out before that. So they do get very compact, they get a lot shorter, and it just tells you where your valence electrons live, which are going to be our important electrons. The other electrons are there, but we don't really care about them. We care about our valence electrons. So I've got some practice here for tellurium and rutherfordium. On my piece of paper, I have an extra one as well, which is sulfur. So we're actually going to do 3 examples in your notes today. So I'm going to go to my document camera here. And I have my colored periodic table. On my colored periodic table, I have my, let me see if I can move this over just a little bit into the window. I have my energy levels all diagrammed out. I have my S, P, D, and F. We had that weirdness going on down here at the bottom with the period 6 and period 7 elements that we had written down, and then some extra information. So we colored this in the orbital diagram unit. Now looking at this, I'm going to focus in down here on my noble gases. And I have a Sharpie in my hand, and I'm just going to take this and I'm going to color the noble gases. And I'm going to label this as noble gases. And as a reminder to myself, with my noble gases, I'm going to put that element into brackets. And that's just to lock everything in and say, hey, I know the electron configuration for argon, or I know the electron configuration for xenon. I'm going to continue on after that. So as we look at this, the first example that I had written down is sulfur. So with my sulfur example that I have here, sulfur is right here on the periodic table. It's number 16. To write out the electron configuration in noble gas format, I'm going to go up to the previous period and to the very end. So the noble gas that I'm going to use here is neon, and I'm going to put neon in brackets. And I'm going to say, hey reader, if you need to know what's really in here, you're going to just need to figure that out. But you know that it's 1s2, 2s2, 2p6. I'm going to continue on with the beginning of sulfur's row. So go to the beginning of the period here. And sulfur lives in 3s2, 1, 2. And then I have 3p, 1, 2, 3, 4. So this shows my full noble gas configuration for sulfur, that I have neon, and then after neon I have 3s2, 3p4. This only shows me my valence electrons. My valence electrons are coming from my third energy level here. So my valence electrons, I have 2 plus 4, that's going to give me 6 valence electrons. Valence electrons come from the outside shell, CE. But for right now, like I said, I don't need to know that information. That's just extra. We need to know that in the next section. I just wanted to show you that both of these are valence electrons from the s and the p orbitals. Now in the next one, I have telluride. Telluride is down here on the periodic table. For telluride, again, I'm going to go up to the end of the last full period. So I'm going to use krypton for my noble gas. Then, once I use krypton here, I'm going to go to the beginning of telluride's row. And I'm going to start off with 5s2, 1, 2, 4d10, because I'm going across all of those, and then 5p, 1, 2, 3, 4. My last one that I have is rutherfordium. That's way down here. For rutherfordium, again, I'm going to go up a row to the very end. And when I go up a row to the very end, I'm going to use radon, Rn. Now I'm going to put that into brackets. When I put radon into brackets, after that, I'm going to go to the beginning of rutherfordium's row. So I'm going to start with 7s2. After 7s2, I have to jump down here and I have to pick up the F block. So when I pick up the F block, I would have 5f14 goes all the way across. After 5f14, I'm going to come back up here, and now I'm at 6d12 to get to rutherfordium. So I would have 6d2. So writing out rutherfordium like this is much easier. It's a lot more simplified, and it's just showing the valence electrons. Valence electrons come from the outermost energy level, so the highest energy level. So this is 6, 5, and 7, so this just has 2 valence electrons in rutherfordium. So I hope that that helps. This is only for noble gas configurations. If it asks for an orbital diagram, you're going to have to draw out the orbitals with the arrows. If you have an electron configuration, that's where you're writing out just like 1s2, 2s2, 2p6, and the noble gas is where you actually use the noble gases in brackets.